This is a demonstration video of our CSE 546 project, which is a network traffic monitoring system for an infrastructure as a service, which is deployed in cloud. The tasks that we perform during the course of this project include cloud environment setup, which is done basically by using DevStack, and which is a development package for OpenStack. Then we also make for traffic monitoring system, we make use of TAP as a service, and the task 3 would be to demonstrate the network traffic acquisition, and task 4 would involve traffic classification and analysis. So what exactly is TAP as a service? TAP as a service is a functionality which introduces port mirroring and OpenStack Neutron component, and this allows tenants and administrators to mirror the network traffic from VM connected to Neutron ports to any other port. So coming to the setup of the cloud environment, so as already mentioned, we make use of DevStack packages, and our network topology would look something like this. We have two VMs, VM1 and VM2, which are on a private network, and so we have spawned two instances, and VM1 is an Ubuntu VM, and VM2 is a Ceros VM. So now setting up of tasks would involve tap service setup and tap flow setup. So service setup is nothing but it is created with the Neutron port, which is serving as a destination side of the port mirroring, that is to the port where all the traffic needs to be mirrored, and tap flow is nothing but a port which is associated a port that needs to be monitored, and you associate them as a tap flow. So you have TF1, which is your tap flow, which is attached to your VM1 port, and your tap service name TS, which is assigned to your port on which you would want the traffic to be mirrored. Now let's check if the traffic monitoring is actually working and if the traffic is being mirrored. So we'll use a simple TCP dump on the port that has been configured to get all the mirrored traffic, and the host which we are targeting is 10.0.1.8, which is nothing but our VM1. So now let's try to ping this VM from a stack instance and see. So yes, so now we can see that the traffic has been successfully mirrored. This completes our task of successful traffic monitoring of all the instances that have been created on our test stack. This TCP dump output can further be uh, sent to a PCAP file, and you can classify the traffic based on protocols or any other classification criteria. So in this graph, we can see an example of number of R packets or an ICMP packet, TCP packet, UDP packet, or SSH packet that are present in the monitored traffic. So in this way, we could classify the traffic that has been monitored. So our next task was to integrate this traffic monitoring system into security, providing security to the entire system by making use of intrusion detection system in order to detect early warnings of any malicious packets. So in order to do this, we make use of Snort, which is an IDS. So first we start Snort, then we check if it's running successfully, and yes, it is running successfully. We make use of Snorby, which provides us a GUI representation of the alerts that Snort captures. Snorby in turn makes use of Barnyard, which basically is a database which collects all the logs from Snort and which can be fetched by Snorby to see to provide a visual representation of the alerts which have been logged by Snort. So, thus, our traffic analysis is done by making use of Snort and Snorby. So, in order to demonstrate the successful IDS implementation, we run Snort on the port which has been set as the tap service port, that is where all the traffic has been mirrored. So, and the rule that we do here, we will be demonstrating a simple ICMP flood attack, and this is the rule for it, and the priority is set as medium. So here is
So
an
he can
example
reject.
of so here is a simple example of ICMP flood attack. So, and we run this. Since we have already started Snort, so we can start the attack. Now we can see that attack's been running and Snort has been running in the background. Now let's stop this attack and check if Snorby is logging the alerts properly. So yeah, so here we can see that the medium severity is since we had set the priority to 2, so we see all the logs being, so here the Snort alert shows that the sensor from this IP to this IP and all the other details regarding this alert. And here we can also see a graphical representation of the event counts that has been logged during each instance of time with the severity levels as well. So this attack was demonstrating by making use of this model. So our DevStack VM was used as the attacker VM, and our VM instance, which was nothing but an Ubuntu machine, was used as a victim VM. So by this, we were successfully able to integrate an IDS and integrate IDS onto our OpenStack instance to provide alerts regarding any malicious traffic that has been entered into our tenant networks. So, so this project completes the successful demonstration of traffic monitoring system and along with the classification and analysis of the traffic by making use of tap as a service in order to monitor the traffic with the help of port mirroring techniques
Asked
in
that.
a cloud environment, and and the future work would involve anomaly based detection, as currently the IDS which we have implemented makes use of signature based detections. So this can be one of the future goals of this project. Thank you for watching the video.